So this is basically the design of the one that Jeff and I have built, and kind of the that thing, yeah. Okay, where's the button here? Okay, over here you see, it's just the air pressure source, and then this one is the compressor with a regulator on there because you don't want the pressure too high, and you want to be able to control the rate that the bag fills. Then there's a bellows here, and this one's a little different shape than the one Jeff made, but I've made some with this design here. It works fine. It's just a piece of wood with a hinge on it and a bag on there. And the bag that we use, I originally used Ziploc bags. I thought they were pretty tough because they advertise on TV how tough they are. But they didn't stand up very long, and so I hunted around for other bags. I went down in the PD department. I got some bags there, and to test and see how strong they were, I stood on one. It still didn't break. And then I jumped on it. It still didn't break. I thought, that's my bag. So we use a 2-liter peritoneal diameter bag. And since then, we've only used one. We've never had to replace it. It just lasts and lasts. And then there's a couple switches, one at the top, one at the bottom, that measure the location of this, so you know how much is in the bag. And the upper one tells when the bag is full, and the bottom one is when it's empty. And then you can adjust the distance between those two settings. That's the amount of air that you infuse into the patient. So that's your tidal volume rate. Basically, it's very simple in how it works. When the machine starts, the valve number 1 opens and valve number 2 is closed, and that fills the bag up here. And once the controller here senses that the bag is full, then it opens valve number 2 and closes valve number 1, and it lets the air go over to the patient here. Valve number 3 is closed, so that pressure that's developed over here fills the patient's lungs. Now, you don't have to worry about overpressure because the maximum pressure that you can achieve in this system is dependent on the weight that you add on here. You can't get more, depending on the surface area in contact with this bellows and the weight that's on there, that's the maximum pressure that you can generate. If you have a patient that, say, needs more pressure, then you just add more weight on the system. Then I have a manometer here, which in Jeff's design, he actually used a electronic pressure controller instead. But I've built some with just a manometer, just like the one that in the old design that we saw earlier. And it's just got colored water in it, and it just allows the people that are running the ventilator to see the pressure fluctuations and how things are working. And you can just look across the room and see that everything is working fine. So anyway, it fills up the patient's lungs, and then you can do if you go by volume control, then once it's gone down to this lower level here, it says I've put this much air into the patient. Now it's time to let the patient exhale, and then valve 2 will close again. Valve 3 will open, and the patient will just exhale. And then you can set a timer on the controller to allow for the exhale control time. And there's different ways that we can make that work. We can just have a fixed amount of time, or we can set it for a ratio of the inhale time. We know how long it took for the bellows to go down, and we can set the exhale ratio at a certain ratio if we want to do that. And then the patient will exhale. And during that time, this valve is closed, so this one can open, and the bag fills for the next cycle. So there's no delay in between cycles. So the patient's finished exhaling, the cycle switches over, and they inhale for the next. They can inhale the next breath. Then here's something that Jeff has put on. He's put a personal computer attached to the controller. The controller is just a standard industrial electronics controller that they use in robotics and stuff. There might be 1,000 of them in factories in this region, because basically when we designed this, we said, well, you can't use parts that you have to order on the internet or wait to delivery. They have to be stuff that you can get. It has to be in the area here. So the valves are just standard water valves, solenoid valves, and they're rated for very high pressure. Now, and these valves are actually very reliable. You can put them in water systems, in factories and stuff, and they'll run thousands and thousands of cycles with water and very high pressures for years and years. So we're not concerned about the reliability of the valves. The controllers, the same thing, are extremely reliable devices, and it shouldn't be a problem with that. You can use good quality switches here. The bag I tested by the jump test, so we're reasonably confident with that. And mainly it's just a question of integration and how well the thing is put together as to how reliable it'll work. Now, the PC is not actually required. You can run the thing without a PC and just preset everything in the controller, and it would just do a preset setting. But Jeff has added a PC because that adds more functionality. If you think about a pandemic situation, you don't, if the patient is in an isolated room, you don't want staff going into that room all the time. They're going to use a lot of personal protective equipment, and they're going to expose themselves to this infection. So it'd be nice if you could have the monitor outside of the room. So here, just, you know, you can just have a cable that runs outside of the room, and all the main functions of the device and alarms could be displayed on the PC there. And in fact, you could network them, and if you had, say, 10 of these in a room, you could have them all displayed at a nurse's station on a single one if you wanted to go that far. The other thing is there's another design that I'm working on with an engineer in the US. And he's working on one that uses a PC, but it's for a slightly different thing. He wants the PC to actually control the device too. And instead of using an industrial controller, he's designing a electronic circuit card that will let the thing work on its own. And also then the PC will be designed so that the screens on it will look like a Puritan Bennett or some other one, so that when you have staff that know how to use that equipment, they would be able to learn it very quickly. You know, and the functions that this doesn't have would just be grayed out on that screen. They would just be there. You wouldn't be able to access them, and that's, you know, quite a ways down the road. But that's another idea that we have.